Hello, and welcome to the first session of Introduction to Data Science with R for Social Scientists. My name is Johannes Gruber. I'm a postdoc at the Chair for Digital Democracy at the European New School for Digital Studies. And if you need to contact me, just pop me an email at gruber@europa-uni.de. So the agenda for today is that I will first quickly introduce myself, so you know what my credentials are and what I'm doing here. Then I will talk very briefly about data science, what it is, and why you should do it using a programming language. Then I will talk a little bit about why I choose R for this course and why I think it makes sense for you to learn it and use it for data science. Finally, I will say a few words about this course and how you should take part in it. So let's get started. A few words about me. As I already said, I'm a postdoc researcher at ENS. I graduated from the University of Glasgow with a PhD in 2021, and I did my thesis on protest coverage in news media. I did so using automated content analysis in R. I'm also an R package developer since 2017. I authored several R packages, and I'm a contributor to several others. The two that are most popular of my packages are LexisNexis Tools and R-WhatsApp, which have both been downloaded a couple of thousand times. I'm an R user since 2015, which is the year when I did my master thesis, and I heard about automated content analysis in R and learned the language specifically for that, although I did a little bit of programming beforehand. So, about data science. What is data science? Hadley Wickham, who's this huge figure in the R universe, defines data science as the process by which data becomes understanding, knowledge, and insight. And he provides this great plot here, which is also in the book that we are using, where he maps out the different steps of data science. So the first step is that you want to import your data into R. So before you can do anything, you need to read an Excel file or a CSV file, or sometimes you want to read like a Word document or a website and so on. Once this is done, you need to tidy it, meaning you need to bring the sometimes obscure format into a nice table-like file or format before you can start the process of understanding what's in the data. And this is usually done by first transforming it again into a more useful format before you can visualize the data and model it. And as you can see here, this process is circular, meaning that you have to do the transformation, visualization, modeling, and so on again and again until you really think, okay, I understood it now, I have an interesting story to tell, so I can communicate it now. A different definition of data science, which is often used, is that you use data and tell a story about it, tell a story with it. And R is fantastic for this because you can basically do the whole thing in this one program. You can start by having this raw pile of data that you can't really do anything with it, and the outcome is a great report where all of your plots and models can be really easily communicated with some audience. And there's another important quote here from Hadley Wickham. I do not 100% agree with it, but I think there's a lot of truth in it, that you can't really do data science in a GUI. A GUI, so a graphical user interface, meaning you move the mouse around on your screen, you click different buttons, and the program will do whatever analysis you want it to do. However, I think while you can surely do this, you see in this circular understanding bit of the plot above that it might be really complicated to do this, for example, in Excel. If you think about it, data transformation, okay, that's still relatively okay in Excel. Then you visualize it, you might already have some experience with that, and you can get some great plots out of Excel. That's fine. You can also do a little bit of modeling in Excel. You can do some very simple correlations, for example, so that's fine. But then what happens if the data underlying your analysis changes? So, for example, you get a swath of new data, or something was wrong the first time. One thing that is really famous in Excel is that it will try to convert everything to dates. So instead of 12.1, you get the 1st of December or something like this. So something changes, and what happens in a GUI, what happens in Excel, for example, is that you then have to repeat everything. You have to do data transformation again, you have to do the visualization again, and you have to do the modeling again. Sometimes you can use some of your old stuff, but it's very prone to error if you try to do that. So usually it makes sense to just do the whole thing again. And I mean, of course, you've learned how to do this, so the second time will probably not take up as much of your time as the first try when you did the transformation, visualization, and modeling, and so on. But the thing is that the third, the fourth, the fifth, the 15th, the 50th time that you do this analysis, you still have to click all of the different buttons to do the visualization and the modeling. You still have to repeat it again and again, and there isn't that much time you can save. It is simply very tiresome to try and repeat an analysis in Excel. And then the second thing is that when you do some analysis, you have to keep very close track of what exactly is it that you're doing. Because if you want to communicate it to someone, those people might have very specific questions, like how did you do this? How did you do that part of the transformation? What exactly were the model specifications? So if you want to do that, you have to take very, very good notes. And the thing with R is, or other programming languages, is that you basically do your notes before you do the actual analysis, because the commands you write down, so the computer knows what you want to do, those can quickly become your notes. You basically save them as a script, and they will be there forever. And at least in theory, when you run the script again, it will do exactly the same analysis given the same data. That means it is always reproducible, and you always have great notes. You can always go back and see what it was that you were actually doing back then. So it's imaginable that you can do data science with a GUI, but it basically means you have to get it right on the first or second try, because otherwise this understanding process, the circular process, you will get tired of it and just let it be. And the second thing is you would need to be a person who takes really, really good notes. And at least for me, I know that this is just something I couldn't necessarily do perfectly. So while you could do data science in a GUI, I think it's actually much easier and quicker for pretty much everyone to do it in a programming language like R. So next, I want to talk about R. Why should we use R for data science? Well, first, it's a language that was specifically created for data analysis and visualizations, which are the main part of data science, really. R has an absolutely amazing community. People are usually really friendly and helpful if you have any questions. But then also this community goes out and just writes the most amazing packages, solving pretty much every problem you could possibly imagine. And this is really something where R stands out, because there are hundreds, thousands of packages that pretty much solve your problem. So you don't have to write all of that code for solving a specific program. You can just download, a package which is basically an extension of R, load it into your environment, and then you can use all of these functions. You can basically employ the code that someone else wrote to solve a specific problem. R also has a really excellent package management system. They have their own server where you can download the packages, and what is really great about it is that every package gets tested every day, again and again. And if one package fails, then the author of this package has a couple of days to fix it. And if they can't manage to fix it, it gets taken down. And you can be sure that everything which is still up on the server works. So this, I think, is absolutely excellent, especially compared to some other programming languages. Data wrangling in R is really accessible and fun. And in my opinion, the main reason for this is that there are some absolutely great extensions. Again, these packages, which I already talked about, there are a couple of them which are subsumed under the term tidyverse, which is just a suite of packages that makes it incredibly intuitive to wrangle data. And it's really, really fun that after some time, you know the exact commands that you need to type in to do some complicated analysis in just a few lines of code. R also has some outstanding repertoire of statistical and computational methods, which is again based on the community effort. But what you need to know is that many scientists all over the world use R, and sometimes if they come up with a great new method, they first implement it in R because this is the language that they're using using on a day-to-day basis. So R is super complete when it comes to all of the standard methods, but there's also some really cutting-edge stuff going on in the R community, and you can just download it and use it completely free of cost. R also integrates really well with other programming languages, which means that if you have a package in Python, for example, you don't need to learn Python most of the time. You can just import some of the functions of the packages that you want to use into R and just use it from there. This is done using the Reticulate package. This is the logo of this package here, and it really shows that Python and R have become friends. So if you're already familiar with Python, it's another great language, and I will talk about it a little bit more later on. R also has some fantastic packages which deal with reporting. So the communication part that I talked about here, you can do this with R Markdown. And the advantage here is that you can basically take your script, your analysis script, and turn it into a PDF or an HTML file or a Word file. And if something about your data changes, or you notice while reading it, oh, there's an error in one of the labels of my data, you can go in, you can fix the data, run R Markdown again, and it will produce a new PDF, a new HTML file with the corrected version of your data. And finally, what I think where R really stands out is when it comes to visualizations. ggplot is the pack, or ggplot2 is the package which is used for that, and it has some really world-class visualization capabilities. I brought this plot here because it's one of the most famous ones of 2020, and it was created by someone at the Financial Times called John Byrne Murdoch, and it showed really early on how the COVID pandemic slowly got out of hand in many Western countries. And this was done at a time, so you see it was in March, where most people still thought, okay, this is probably not a big deal, but we need to check that our healthcare system isn't overwhelmed, because this is what basically happened in Italy. And when you look at these lines, you can see that Germany and France and Spain and Switzerland and the UK, all of these countries basically had the exact same curves compared to Italy. And it was really dangerous for these countries for a long time. Hundreds of thousands of people could have died if those countries wouldn't have implemented some kind of measures so that less people get infected with COVID. And John Byrne Murdoch has said that he basically did this plot in the break at his work at the Financial Times, and he just typed up some ggplot2 code, looked at this and was like, oh, this is actually really interesting. And he said that he since then developed this plot further and further and further, and you've probably seen it in some shape or form for your country, because it has become basically the standard of how you communicate COVID numbers or case numbers in most newspapers all over the world. And the first version of this was done with ggplot in R. So next, I want to talk a little bit what specifically we will use. We will use two pieces of software in this course. One is R, and the other one is RStudio. And sometimes people get a little bit confused about the difference here. But R is free and open source software. Actually, both of these softwares are, but I just wanted to highlight it. You don't ever have to pay anything to use R or RStudio. R is a programming language and programming environment for statistical computing and graphics. R is meant for analysis, and it makes analysis reproducible and you can automate it. So, for example, if you want to track COVID cases, you could automate it by running a script every day that downloads new numbers and creates a new plot and, for example, sends it via email to someone or displays it on a website or something like this. It's really easy to do once you get the hang of R, to basically run a script again and again. R is available on pretty much any processor architecture today, and also on almost any operating system that you can imagine. So it's available on Linux, Windows, and macOS, of course, and I think this is mostly what you're using. And it's also generally easy to install. I will upload videos on how to do it on those different operating systems, and it's just, it's rather quick and easy. So there's no need to be afraid of it. Then RStudio is an integrated development environment. It's not an alternative to R, but it's an addition. And it adds a graphical user interface to R. So, I mean, earlier I told you graphical user interfaces are bad, but it only adds a few key features that help you to write your code better and to do your analysis more quickly, still using R. And you can imagine R as basically the raw engine. And if you think about it, you could put it in pretty much any vehicle, and you could go 300 on the Autobahn if you really wanted to. But what RStudio adds here is basically like a dashboard of a car. So you have a nice steering wheel, you have a sat nav, you have a brake and accelerator, and it makes it much more easy to tame the raw power of the engine and to know what you're doing. So RStudio is really fantastic to basically tame R and give you something nice to look at while you work with this programming language. But you need to have both installed, and then you open RStudio to do your analysis in the R language and software environment. So why should you use R and not something else? Or could you use something else? Is there something else out there that is even better than R? First of all, let's talk about commercial software for data science. I already discussed Excel a little bit. There's also SPSS, which is a software for statistical analysis and visualization, so similar to R. But the problem there is, again, that both of them rely on a GUI. So you can only do exactly what the companies behind those two software packages intended you to do with it. So you can only run the statistical methods that have been implemented in SPSS, and the same is true for Excel. And again, you have to repeat all of the different steps, and you have to take notes, as I said earlier. Stata and SAS are a little bit better because they are actually programming languages. You can do reproducible analysis in them. The problem is, again, they are commercial software. We can't look at the source code. You can't change much about them. There are also extension packages for Stata, but they're very rare and there are not that many of them. You basically have to wait until Stata releases a new version. Then you have to buy this new version for a lot of money to use one of these new methods. Then on the other hand, you have open source software, which I'm a big fan of, and there are basically three competitors to R in this place, which is Java, Julia, and Python. So Java is, in theory, a great language for data science, and when you see some of the data science like programs that are sold out there, they are written in Java. The problem there is that each time you want to do a new analysis, you basically have to write a whole computer program here. So the joke on the right side here is that before you can build a horse, you have to build this horse factory. And this is really true. Like, this is my experience with Java, which is, I don't have extensive experience, but this is what I felt is the core of Java, that it gets massive very, very quickly. You want to do one tiny little bit and you have to build all of this stuff around it for it to work. So the second alternative would be Julia, and Julia's fantastic. It's super fast. It's also free and open source. The problem here is that the community is just not as big. Not a lot of people are using Julia, and it's just not as accessible. There aren't as many tutorials out there. The user base is just much smaller. It will be much harder to find someone who has a similar problem to yours if you need some help. And then finally, there's Python, which is probably my second favorite programming language for data science. It has the big advantage that it is a general programming language, so that means you can do all kinds of stuff in it. You could basically program a whole operating system in it, or everything you want, really. But this is also a bit of a disadvantage because it isn't specifically developed for data science or visualizations. You have to load in all these different packages before it can really do anything. It doesn't even know what a table is. It basically only knows lists and vectors, which are like really basic units in programming. And the second thing about Python is that it gets very frustrating finding help, in my experience, because often people assume that you already have some experience programming, that you're a software engineer or something like that. So the community sometimes gives you like really cryptic answers. It also has a bit of an issue with package management. So in R, this is absolutely fantastic. It gets tested every day and you only get the software that actually works. Python, in my experience, is much rougher. You can install one package and then you install another and they have some kind of weird conflict and it all basically falls apart. So while Python is great, I think it's a little bit more advanced. And if you really find something that is only available in Python and not in R, again, you can basically remotely control Python. And this is also true for all of the other languages mentioned here. You can basically remotely control those programs and get the bits that are really interesting for you and use them directly in R. How can you get help with R? I wanted to cover this in this introductory session because you will quickly run into some weird problems that you can't really figure out on your own. And I just wanted you to know this is completely normal. Don't get frustrated by it. Everybody is experiencing some form of issue where you look at it and think like, what does it mean? How can I solve this? And I just wanted to let you know, even I look stuff up, everyone does. And there are some great tools out there that you can use to get help and solve your own problems. The first thing that you should do when you have problems with a function is to type a question mark and then the name of the function into R, because this will help open a help page, manual page, where the developer of this function has given you some clues on how to use it what exactly the function is supposed to do. And you often get a couple of examples. And if you run these examples, often you will understand quite easily, oh, this is what I did wrong. I didn't enter this command, or I messed up the order of some things, or something like that. So the help page in R itself is fantastic, and you should always go there first and see if it solves your problem already. If this doesn't help, go on Google and just type R and then the error message into Google. It's important to type R so you get specific results for the programming language and not for Python, which often has similar error messages. So type R and then the error message, or type R, then what you want to do, and then the package you want to do it with. So as I mentioned earlier, we will use the tidyverse a lot. So if you wanted to do a bar plot, for example, you could enter R tidyverse bar plot. And I will assure you, you will get some great answers and tutorials. The first thing that I would usually look for when looking at the results on Google is if there are answers on Stack Overflow. This is a Q&A platform for programmers, and it has a subsection for the R programming language. And usually the answers there are somewhat complete and will help you. Sometimes you have to look at a few different questions and answers before it solves your problem, because other people do very specific other stuff, or the question has been asked a long time and the underlying package changed. So look at a few answers. Usually it makes sense to go to the newest one, but there are answers out there from like 10, 15 years ago that are still valid today. So Stack Overflow, really good resource. Then there's a website called community.rstudio.com, and it is very similar to Stack Overflow, but it is specifically made for R. I would always recommend using Stack Overflow, but some of the more specific problems, there are answers on RStudio, and it is generally a really welcoming, cool community there. So sometimes people get turned off by Stack Overflow because some of the answers can be a bit mean. If you feel like this is the case for you, go to community.rstudio.com. And the third resource that I would recommend is rbloggers.com, which is basically a Combinator website where people who write blogs about R can upload their blog posts. And you see it in the example here on the right. Object of type closure is not subsettable. This is a very famous error in R because it doesn't really make sense for a very, very long time until you get a really deep understanding of R. But it tells you about very specific problems if you kind of know what it means. So the bloggers post here is probably a good idea to read this if you come across this problem relatively often and you want to understand, like, what is going on? What am I doing wrong? Also a good resource. You can also, instead of looking for questions and answers on Stack Overflow, write your own. But since the platform is so big and since it has been around for so long, that is almost never necessary. Usually Googling it for a bit helps. If none of these above methods helped you, I also added a help forum on the Moodle page. And the idea here is that you can post your questions there. Make sure that you include a bit of code and try to describe your problem as best as you can. And then it would be great if all of you went to the help forum from time to time and checked if there's someone there who needs help. I will check it regularly, but I think it would be a good idea if you would try and just help your fellow students there so they get an answer more quickly. Sometimes it will take me a couple of days to see that there's a new question. Yeah, just try and help each other there. And then if you still don't have an answer, note your questions, and you can ask me at the help desk sessions. I will talk a little bit more about them later. But of course, I will help you eventually with all your problems if you are not able to solve them in one of the suggested ways here. So about this seminar, how does a session look like in this course? We closely follow the book R for Data Science by Hadley Wickham and Garrett Grolman. And this book is available online. It is free and open source again. So yeah, you don't have to buy it. Just read it online or download the PDF, which I will post on Moodle. For each session, I want you to read one or several of the chapters and try to do the analysis in them by yourself. Once you've done this, I want you to watch the video that I will upload for the session. And in these videos, I will basically go through the analysis again, tell you some more information on the different functions presented there. And I think it helps to basically see someone else do it. And yeah, as I said, I will also try to do a little bit more than what is in the book, just to help you understand what is going on, which is sometimes easier when you see it, and also just by repeating it, it will be easier to understand and to use it on your own. Then in the book and on Moodle, there are different homeworks, and it would be good if you did them. They are not part of the course assignment, but doing this presentation without doing the homework will be much more difficult. I can already tell you that. So do this homework. You can send it to me, and I will see if what you did is fine. And I can correct some errors, which I think is important, because if you do something wrong and you keep doing it, and even though it like barely works, I can let you know easy on if there's something you could improve to better understand the code you're writing and to do the analysis that you're doing better. Or also, if you get stuck with this homework, you can post in the help forum or let me know, and I will help you to complete it. As I said, if you have questions, you can post it in the help forum. If those questions are specific to your data science project that you want to do for this course, note them down and we can discuss them in the help desk sessions. And that is it for today. Thank you for watching the whole video, and I'm looking forward to seeing you in the first help desk session.